Hello, this is Jim McKeeth from RemObjects Software. Welcome to this session on data abstract cross-platform application development. Here's a short agenda on what we're going to cover. The times on the right are for if you're watching this in the replay and you want to just jump to a specific part, or you can jump to that time index and get there. I'm going to start with a short introduction of data abstract as well as some information about cross-platform application development. Then we're going to do a demo. I'm going to show using data abstract with FireMonkey and live bindings, show you some daSQL, and then we'll look at deploying our data abstract application to the Mac, and we'll look at the new data abstract server explorer. Finally, I'll end up with another demo on master detail with daSQL. This slide will be available again at the end, but I wanted to put this in here now to let you know that also there's some videos available at remobjects.com/tv/da, where you can actually go into a little more depth on a number of the things I'm talking about here, and hopefully some of the information from this video will show up in other videos there as well. So real quick about data abstract. Data abstract is the premier multi-tier database application framework. It's built on our award-winning RemObjects SDK services platform, and it just takes multi-tier database applications development to the next level. It makes it very easy to use, and it's very powerful and very secure. It's multi-platform, and so what that means is we have different flavors of data abstract. One for Delphi and Free Pascal, one for .NET and Mono, one for Xcode for iOS and OS X, and then we have JavaScript actually is built into those other platforms, so you can build JavaScript clients. So it's not actually, the JavaScript one's not actually a separate flavor, it's part of the other flavors. And then we also have the Java version coming out soon as well. So with that, with the Java versions out, really you'll be able to run data abstract on any platform out there. And the great thing about data abstract is that it's native for each of those platforms. So the library is rewritten from the ground up to work on each platform natively. So data abstract makes building cross-platform applications with centralized data very easy. So this means you can have your application developed, a native application for each of these platforms, any platform, and then all those applications can then share a centralized data source. Obviously, there's the Windows platform. On the Windows platform, you have a number of tools options available to you, but most likely, everybody here at least is going to pick Delphi. And the reason we pick Delphi, among other reasons, is because we like the fact that Delphi gives us access to the native widgets to that platform. So when we build an application in Delphi, it looks like a Windows application. As opposed to if we're using Java for Windows application development, usually a Java application doesn't look native because it uses the Java components instead of the native Windows components. So that's the reason we choose Delphi for Windows application development. Then if we're building a web application, we're probably going to use ASP.NET, just because ASP.NET has some great support with the MVC framework, for example, for a lot of the latest web technologies. So ASP.NET is a great way to get to the web platform. Again, we have a lot of choices when it comes to building Mac OS X applications or iPhone applications. But if we want to get the native widgets available on Mac OS X and iOS, we're probably going to go with Xcode. And so that's why it's important that we have data abstract available for all these platforms, because then if you choose these native options to reach these platforms, you can use data abstract, and then all of these are able to talk to each other and share information. As I mentioned before, we have support for Java and Android coming soon with data abstract, so then you can actually add Java and Android into that mix. So when you're using data abstract, it has supports for all these databases and a number of other ones. It's very easy to add drivers for other databases to it. First thing you're going to do is you're going to pick your database, what database you want to use. We're familiar with the traditional client-server approach, I'm sure, where you build your client application, and then your client application has some sort of direct data access layer that's going to talk straight to that database. And then in your client application, you're going to add the user interface that's going to be how the user interacts with the application. And of course, probably the most important part that a lot of people forget about is the business rules. The business rules are what makes the data useful. It controls how the user is able to interact with the data. So the business rules are what makes the difference between someone just being presented with a table of data and a person being presented with meaningful information, maybe addresses plotted on a map or an address book or whatever it is. So the business rules are what makes the data useful, and oftentimes is probably the bulk of the application. So when you're doing cross-platform application development and you use the client-server approach, you end up with 3 different implementations of your application. And each of these implementations, of course, has a different user interface, because you're not going to have a shared user interface between a Windows application and a web application, obviously. And you're not going to have the same application on your iPhone that you're going to have on your desktop, because you have totally different conventions and totally different restrictions as far as the size of the screen. So the result is you're going to have to develop these different applications for these different platforms. But then your business rules have been replicated 3 different times. Now at first you're like, oh, that's fine. I'll just, fork the code or whatever, translate it once. No big deal. But then the result is that you end up having variations happen and things happen, and you end up having to maintain these business rules in different locations. So this is just not a good approach for doing when you're considering building applications that are going to be ran on multiple platforms. So the solution, of course, is to take the business rules and the data access out of the client application and put them in the middle tier. And then the client is going to use a middle tier access library to talk to that middle tier. Now, when we introduce our different client applications, each with their own user interface, we don't have the replicated business logic. The business logic is all isolated in the middle tier, where it's not reproduced for each different application. This makes it easier to add a new application in the future. So if another platform comes out we want to support, no problem. We don't have to reproduce the business logic for that new application. All we have to do is create a new user interface to interface with the existing business logic that's isolated in the middle tier. The other great thing about this is that when the clients are connecting to the middle tier from over the internet, the middle tier is able to act as a gatekeeper with the thanks to the business logic. Since the business logic governs how the data is interacted with, the middle tier becomes this gatekeeper to the data. It keeps the data safe. If the business logic is instead in the client application and somebody connects with their own client to your middle tier and the business logic is not in the middle tier, then they've bypassed the business logic and they're able to get full access to your database without the restrictions that the business logic put on the interactions of the application. One of the great things about the way Data Abstract builds a middle tier is that the business logic is contained in what's referred to as the schema. The schema is a abstract document, if you will, that contains all the business logic, all the rules. It knows how to talk to the data access layer. So the business logic takes the complexity out of building middle tier and makes it easy to work with. So some of the great things about a schema is that you can use our schema modeler tool that makes designing the schema easier. It keeps all the user code database agnostic because the user code is written against the schema, not against the database. So that means if data changes happen to the database in the future, then you don't have to update all your clients because the schema abstracts out the data model from the database. And then probably the coolest feature in the world that schemas allow for is what's called daSQL. So since the schema sits between the client application and the database in the middle tier, that means that if you can actually write SQL in the client, like this here, that's going to select all the customers where a customer ID equals this. That is written as a daSQL statement. That daSQL statement actually is interpreted by the schema. Now, since the schema abstracts out the data model, the schema might represent different tables for customers, for example, and have different rules that are applied as far as how the user interacts with the database. So then the schema is going to generate new SQL. Like here, it's going to say select specific columns from that table, and the table's got a different name. It's called custs. And also it's going to restrict this user, based on the user, it's going to restrict the user down to a specific region. So this user can only see customers in region 78. So that DB SQL is generated by the schema and sent to the database. So the great thing about this is other multi-tier systems either A, restrict you to only pulling specific pre-defined sets of data from the middle tier, or B, allow you to send SQL from the client all the way to the database server. The problem with the first system is sometimes you're going to run into a set of SQL or situation where you're like, if I could just write some SQL in the client, I could be done, but you can't. And you understand that that's a good thing, because if you were allowed to write SQL in the client that was passed clear through to the database, then you would bypass all the business logic. Your database would be vulnerable to all sorts of exploits. So that's the great thing about daSQL, is it's the best of both worlds. It gives you the ability to write SQL in the client for maximum flexibility, but it gives you the full safety of having that SQL ran against the schema in the middle tier, and all your business rules being enforced before that SQL gets to the database. The other great thing about schemas is, since the schema is a complete abstraction of the business rules in the database, that abstraction actually allows us to build our Relativity Server. Relativity Server is a reusable middle tier that you just load a schema into and define settings for it. And it's a reusable middle tier, so you don't have to keep redeveloping a new middle tier each time you have a new application that goes out. So I'll show you a little bit about Relativity Server today, but like I said, on that site, we have some more information on it as well. Go check out the video or read about it on our website. Sometimes you have to deal with load balancing. One situation with load balancing is you can actually have your middle tier, whether it be Relativity or one of our custom middle tiers, talking to multiple databases. So multiple database servers distribute the storage load to provide load balancing. That's one form of load balancing, probably the simplest one. The second form of load balancing is when you have more load than a single middle tier can handle. So you set up multiple middle tiers, each middle tier talking to one or more databases behind the scenes. Then you use like a round robin DNS or some other mechanism to change so each new request goes to a different middle tier. Of course, the problem with this is your session. Since the session is maintained by the middle tier, and a client may get a second connection to a different middle tier than they had previously, they would lose their session information. The solution to this is our Olympia session server. So the Olympia session server can be installed on your network, and it automatically synchronizes sessions between all the different middle tiers that you have. And so that way you can have the maximum flexibility of having as many middle tiers as you need, but then the users can have their state maintained between all those middle tiers. So as they're moved from middle tier to middle tier, in order to balance the load, their session moves with them automatically. And so now for some demos. Data Abstract offers a wizard in the Delphi IDE for making new projects. Now, by default, it's available here. We can go ahead and customize, add both. We'll go ahead and add both these in here. So now we can come in here and make a new application easier. Now we have two wizards now. There used to be just one. We have the FireMonkey application and the VCL application. Since you've probably seen the VCL application wizard, I'm going to go ahead and stick with the FireMonkey application wizard today. The running of the wizard itself is going to be the same for both types of applications. The result is going to be what the output is created. So there's 4 choices here. It used to be, a few versions ago, this was the only option we had available in our wizard, and it would create a new client and a new custom data abstract server. And the custom data abstract server you'd point it to a database, it'd connect to the database, it'd enumerate all the tables in that database, creating data abstract data tables in the schema for you, publishing those, and then creating a client that was able to consume all of those data tables. That was a great way to get started, but we've since introduced our Relativity Server, which is the reusable middle tier, and figured you'd want to create a client just for a Relativity Server. And of course, this here creates a client just for an existing custom data abstract server. So both of these only create clients. Now this option here is kind of an interesting mix. It creates a single 2-tier client server application. So it's a single application that has both the middle tier, the schema, and the client code all together in one application. It's a great way to maybe leverage the existing schema you have, or if you're just used to working with data abstract and want to create a client application, a simple application. If you want to start with a single monolithic application and later move it into a 2-tier or 3-tier, this would be the way to go as well. For right now, let's go ahead and just create the client and a new custom data abstract server here. At this point, I would specify what database connection I want to use. I'm just going to stick with Firebird because Firebird's cool, and we'll use our PC Trade sample database that's available. Instead of including all the tables, I'm just going to include product groups and products just to make things a little bit simpler. And I'm not going to include a login service. If you wanted to validate your users, which is generally a good idea for database applications, you'd want to have a login service, and that would require users to provide a username and password. I'm not going to use a login service because you know what? It makes the demo go a little easier. And then we'll give it a name, and we'll just call it and here is our project group with our server and our client in it. Now, if you're wanting to modify your schema beyond what comes out of the wizard, you can go in here and find it in here. This is where your schema lives right there. And you just right click and say edit schema. And it brings up your schema modeler. And from here, you can tweak some of the fields and columns. But if you want to add some rules around it or change the display information and stuff like that, you can do that from here. I'm going to go ahead and run this though. And there it is. And we'll close these two out. And let's jump over into the client. So in our client, we have a client data module here. This is where your remote data adapter and all the information that's needed in order for connection to be made from the client to the server, including all of our data tables and data sources. So I'm going to go ahead and select our two data tables we created here. And I'm going to set active to true. Now, one thing about setting active to true with data abstract data tables is there's another option down here at the bottom called store active. Store active is whether specifies if the active value is actually going to be stored. And so this way you don't have the issue where sometimes, you set the data table to true to get design time data, or you set the data table to active to get design time data, and then you go and run it and you got to open it again, or you got to make a change because in your code you're not expecting the data table to already be open, and you get an error message. So this way you don't have to worry about that because it assumes that if you're setting active to true, it's only for runtime. That's a really nice little feature on there. So now we're going to put down some string grids. String grids. Let's put down one for right now. So here's our string grid. And I'm assuming there's other sessions you've already seen that tell you all about live binding and stuff like that. But let's go ahead and show you how we're going to live bind this to our data abstract source. Now, if you come in here and there's nothing there, the reason is because you didn't update, or you didn't open the client data module first. Delphi doesn't actually construct the data module and the things that are on it until you open it. So if you just go into your application and you don't open your data module first, then this list will be empty. Since this list is not empty, I'm going to go ahead and select groups. And there we go. We have our product groups being displayed here. So I'm going to go ahead and go into the columns editor, and let's remove everything but name and make name a little wider. There we go. So now we have our product groups being listed there. And let's go ahead and put another grid down here. No, not in the child of that one. String grid. Let's put it here. And this one, we want to also link, and we're going to link this to products. And there we go, it's linked to products, displaying the product information. We can go ahead and run this now. And nothing's there, because as I said, that active is not stored by default. So we'll go ahead and go in here and we'll say client data module dot table product groups open products open. And now we'll run it. And we'll see that it's open. Of course, I could have used the stored active property on the tables, but in production, you're not likely to do that. Usually, this is what you're going to do. You're going to individually open them after you call login. But remember, I didn't have a login set up on this one for the demo. So now that's pretty nice. I have two columns here, or grids here I can scroll through with data bound to it, but I want to get a master detail. So how do we get a master detail? The way to get a master detail is you got to come back into the client data module, and I just select the products, and I'm going to specify a master detail here. So I'm going to come here and say master fields. And I hit this ellipsis right here, and it brings up our master detail wizard. And we say we want to get it from the product groups. And this is going to use the dynamic where, which is a really cool feature of Data Abstract. And we just specify the field. So we're going to use the group ID and the product group that we want to have the relationship between. And that's it. We're done. And now when we run this, we have a master detail relationship between these two. Pretty cool. In the real world, usually the no code necessary demos don't really pan out very well. So this is a little bit more code involved here, and I'm going to show you some really cool features of DA. Only some of them, though. There's too many of them to show all in 1.5 hour here. This is going to be a daSQL demo. Now, daSQL takes advantage of the schema and lets you run the SQL, write SQL in the client application, and then run it against the middle tier. And then the middle tier then creates SQL that runs against the server. So I'll go ahead and actually let's jump in here. This is the code that's going to actually do the daSQL query. This here is just cleanup code that's going to clean up the grid in the table in case there was a previous data set had been loaded in those. This right here is the daSQL query code. And what we're going to do is we're going to create a table request info version 6, which is the one that is able to handle custom SQL. And these are automatically freed when they're passed to the data adapter here. And we pass in the SQL statement that comes from the memo here. So in the memo, we can type in a SQL statement and it'll pass it in there. And we're going to tell it we want the schema back. Now, this getting the schema back means that we want to actually have the description of the table so that we can then populate the grid based on the fields we received back. So that's what this is doing here. It's going to spin through all of the fields that are returned in DA mem table. So the fill, we just pass in the tables we want and the table request infos. So this is an array. You could have multiple table request infos and multiple tables, but in this case, just one. So here we spin through all of them. All we're doing is just assigning the field name. And then this is a workaround. I noticed that the last column's not showing up unless I do this. I don't know why. It'll probably be fixed in the next update from FireMonkey here. And then the last thing we're doing is going to turn the data source back on. So we'll go ahead and run this. And this is set up to use Relativity or not use my Relativity Server. I'm just going to stick with Relativity Server for now because I'm going to show you some cool things with that here shortly. So go ahead and connect. Here's the two tables I have exposed to Relativity, groups and products. Now you're going to notice those these are named differently because I've already modified my schema. So we're going to go ahead and select all the groups. And so we can change this SQL here and say select name. We'll just get the name and we can say order by name. So now we'll go ahead different order by, and we can say where, let's just do this. Let's go back to that, and 1 equals 1, because that just holds that there for me. And we'll say where ID is greater than 10. 10. And so that'll get rid of dot matrix printers for us. Oh, okay. I got where in here twice. Let's take that out. There we go. Now we've removed all the low IDs. You could also put in, if there is parent IDs in these, obviously I could put a grouping on that. Number of things we could do. So let's just go back to just the name. So that's what daSQL lets you do. Let's go ahead and deploy this on the Mac, and we'll take a look at some more stuff with this. First of all, we'll see that, yes, it not only works with FireMonkey and live bindings, but it works on the Mac as well. So we'll go ahead and change our target platform to Mac, and we'll jump over to the Mac and take a look on it there. And on the Mac, we just wait a second, and it pops up. The IP address is pointing back to the other server still, so we just hit connect. And there's our enumeration of tables. I'm going to go ahead and select all from groups. And there we go. So this parent ID, like I mentioned, is empty all the way down. So let's get rid of that. And instead of filtering it each time in the client app, let's go ahead and do that in the middle tier. And how we do that, how we modify the schema, since we're running against the Relativity Server, is with DA Server Explorer. This Data Abstract Server Explorer is the version for Mac. There's one coming out for Windows that's similar to this as well. The reason the Mac version was released first is there was not a Data Abstract admin tool for the Mac or a schema modeler for the Mac. So this tool, Server Explorer, combines Relativity admin tool and schema modeler into a single application. So the Windows version, like I said, is coming out soon. It will be similar to this one. If you're not familiar with it, this has used zeroconf in order to discover that server over running on the other machine. From here, I can then change between static login provider and LDAP login provider and configure those login providers. This is the login provider at the admin level, admin login. There's also a list of drivers that are available. You can add other drivers to this as well. Those are the drivers that are enabled to talk to the databases. These are the domains that we have. It ships with this PC Trade sample domain setup, which I'm using this domain 1, which is just a custom domain for this demo. From here, I need to specify the data and relativity password. This is relativity with capital R, is the default password to connect to the Relativity server. And the reason I have to provide that is because Server Explorer actually connects to the database through the middle tier. So it can't connect straight to the database. And so that means I need to have this username and password in order for it to get to the data. From here, I can change the data login provider or configure it. There's my connection using the SQLite database right now. And here is my schema. So from here, I can actually preview the data in those tables as well. Or I can hit Edit Schema and come up here in Schema Modeler. So I'm in Schema Modeler now. We see two windows here. This window is the database view. So this is actually showing all the tables in the database, which we see it has more than are shown over here. Also, my groups table is actually the product groups table in the database. So here I've just changed the table name so it doesn't reflect, so it's not the same name as is there. So what I want to do is I want to come in here and go ahead and remove this field. So we see we have the three fields here. So I just come in here and select parent ID and say remove fields. It says, are you sure? Yes. And it's removed that field. So we see it's not listed there anymore. Now in the database, that field still exists on that table. We haven't modified the database. All we've modified is our schema, which is what we're publishing to the client. Go ahead and save that. And we'll pop back over to our client and run this query again. And boom, just like that, we now no longer have that column there. While I'm in Server Explorer here, I'll go ahead and show you a few more things about Schema Modeler. There is this is a new feature we have here is scripting support at the client, at the schema level, and scripting support at the table level. So at the schema level is where you can add events. So I have after login, before commit. There's other ones in here, for example, create transaction. And you can just go through and select any of these events. They're all documented here in the scripting API reference. And we also have a chapter from our book we are writing that covers a lot of this as well. But there are a number of objects available to you as well as parameters. So for example, in after login, you might look at the user ID and maybe determine that user's access level and then store that access level in their session here. And then that session can then be accessed later from, for example, from these scripts here. So from here, we might have a before get data script that looks at the session to determine what data they have access to. And so this is where you might add some row level security in. This is all written in JavaScript. Like I said, there's a number of objects that are available to you here from the scripting API. You can read more about those. One thing though about the table level here is we have this two options here. We have server and client and server. Now server scripts only run on the server. And that's important because the server is your gatekeeper to the database. But client and server are scripts that will run on both the client and the server. So these scripts also run on the server to provide that gatekeeper functionality so they can lock users from doing things you don't want them to do. But these scripts also download to the client. And then on the client, they run to provide immediate feedback to the user whether or not they've met validation. So that way you reduce the load on the server and have faster feedback to the user. So it's a win on both sides. Both of these things can be changed and they're not going to affect the client. The client does not be recompiled. And since I'm using Relativity Server or any of our servers, the server doesn't have to be recompiled. It's just a change in the schema. So there we go. That's a quick overview of what you can do with that. And we saw the change that we can make here while the client's running. So now what do we do with daSQL now that we have this? I'm glad you asked. We're back here in Delphi XE2. I've modified our project. Now we have 2 string grids and 2 data tables. Here we have a master table, which is a DA mem data table, and a detail table, which is a DA mem data table. We also have our data sources attached to those and binding scopes attached to those string grids. In here in our connect, where's that? There it is, connect. We're going to select star from groups. Now, if remember, we modified our groups table, which actually represents the product groups table in the database. We're publishing it as groups, but we've modified the published table to only have the 2 columns, ID and name. So we're only going to get ID and name. And then I'm going to bind name to the grid. So we're only going to show the 1 column in the grid of name. Now, on the data source change for the master table there, we're going to do a select name and warranty from products where group ID is master table, field by name ID. So we're going to get the ID from the master table and we're going to use that to create a new SQL statement here. So we'll go ahead and run this. And here we go. We have a master detail created with daSQL. Now, earlier I showed you how to do this using the master detail relationship on the data sets. But as far as the server is concerned, you're effectively doing the same thing. Because they're both using the dynamic where functionality, which is what daSQL is based on. And what that means is that the server receives requests only for the individual rows that match this for products. So we're never actually querying the entire products table. This is great if you have a huge products table and you don't want to pull the whole thing down at once. A great way to optimize the data transfer, optimize the load on the server, and optimize the amount of data you're going to display on the client. The reason we're using daSQL here is just to show the functionality of daSQL, because every previous system I've used where I want to middle tier system, there's always comes a point where you're like, oh, if I could just write some SQL in the client, I could get this done, but you can't. So this is a great way of showing the additional functionality you can have of being able to create the SQL in the client that runs against the middle tier. And then the middle tier enforces all your business rules, all your restrictions, does all the mapping to the tables, and then runs that against the database. So you're not violating your middle tier. You're not violating any of your business logic by doing this. This is just giving you that additional functionality. One more thing I want to show you here. which is going to be kind of contrived, but it's a great way to show this off. We're going to give our products table here an alias of p, and we're going to say p.name, and then we're going to also go g.name as category. Okay, and so the next row, and we'll do from groups G. So I'm going to also do a join here between the groups and products table, which is kind of contrived because we're showing the group already on the left there. So we're going to duplicate the information, but this is just to show you that you can do joins between tables in daSQL, which I think is really cool. And let's see, we got to go group.id equals group ID, and so if I type that all right, this should work. And we hit connect. Sure enough, so we have the category here joined from another table, brought in for us to display in this same data set. So just a touch of what's available with daSQL. There's a full daSQL sample that ships with DA for Delphi that you can take a look at. It's not for FireMonkey, but as you see, it all works the same with FireMonkey as it does with VCL. Just you got to use the live bindings and all the normal stuff we expect with doing a FireMonkey application. I hope you've enjoyed this session, and I hope you got a lot of information out of it. If you would like even more information about our products, Data Abstract, you can go to remobjects.com/DA for the product page. There's our wiki with all the product documentation in it. And like I said before, be sure and check out remobjects.com/TV/DA for a number of videos about Data Abstract. If you do have any questions, please do email me, jim@remobjects.com, or you can follow me on Twitter as Jim McKeeth. And now, I look forward to your questions.